MCV for U1, Chapter 5, Session 5. In our previous lesson, we used first principle and we proved derivative of e to the power of x is e to the power of x. Therefore, if we use constant rule, derivative of c times e to the power of f of x when c is a constant is c times e to the power of x. We also used chain rule. We saw derivative of e to the power of f of x is f prime of x e to the power of f of x. E to the power of f of x is combination of e to the power of x and f of x. Therefore, by chain rule, the derivative of e to the power of f of x would be f prime of x e to the power of f of x. In this section, we work with the derivative of b to the power of x when b is a constant. We know b to the power of x is the same as b to the power of x e to the power of x line of b. Therefore, derivative of e to the power of x line of b would be e to the power of x line of b times line of b. And this means derivative of b to the power of x, function b to the power of x, is b to the power of x line of b. If we apply chain rule, derivative of b to the power of f of x would be f prime of x b to the power of f of x line of b. The textbook use first principle, and knowing that limit of b to the power of h minus 1 over h as h approaches b is line of b, and they proved limit of b to the power of x plus h minus b to the power of x over h as h approaches 0 is b to the power of x line of b. To show limit of b to the power of h minus 1 over h as h approaches 0 equals b, you can consider a couple of cases equals line of b. You can replace b by a couple of numbers like 2, 5, and use a table of values and show this. In summary, limit of b to the power of h minus 1 over h as h approaches 0 is line of b, and derivative of f of x equals b to the power of x is line of b times b to the power of x. Let's find the derivative of y equals 7 to the power of x2 minus 6x plus 1. B to the power of f of x. Derivative would be b to the power of x, f of x, which is 7 to the power of x2 minus 6x plus 1, times f prime of x, 2x minus 6, times line of b, which is line of 7. One more time, derivative of b to the power of g of x is b to the power of g of x times line of b times g prime of x. Let's look at example 2 on page 238. On January 1st, 1850, the population of a town was 50,000. The size of the population since then was modeled by PT equals 50,000 times 0.98 to the power of t. When t is the number of years after January 1st, 1850. What is the population of that town in 1900? Basically, we are looking for p at 50. We replace t by 50 and we find the population of the town. And the next part is asking, what is the rate of change of population at that time? The answer to this part is p prime of 50. Derivative of the function is $50,000 times 0.98 to the power of t times line of 0.98. In this case, b is 0.98 and p prime of 50 is negative 368 approximately. That means the population of the town is decreasing at approximately at the rate of 368 people per year. As we know, the function is decreasing and population of 50,000 is the maximum of population. Next session, we are solving questions from exercise 5.2, question 1, part C and E. Question 6 are 2 questions that we work on. Thanks for watching.